Human-in-the-loop adaptation for interactive musical beat tracking. The performance of the beat tracking technique has improved dramatically through recent DNN-based approaches. However, a perfect beat tracking algorithm is difficult to achieve in principle because the perceived beats differ for each individual interpretation. For example, one interprets the beats of a music like this. Some people's provides a different interpretation like this. And also, another people's listen as this. As shown, there is no unique answer for correct beat tracking result. To address this, we propose a human-in-the-loop system for adapting the internal model to the user. In this system, the user does not need to correct all errors manually, but rather only a small portion of the errors. The system then adapts the internal neural network model to the target, and automatically corrects remaining errors. When the user inputs the target music, the system first indicates the analyzed beats on the screen. The user can check the result by playback. The system also represents the beat position by clicking sound like metronome. The user can correct the result by moving a beat, removing an existing beat, and adding a new beat. The system also provides several other options for correcting the beats, including tapping tool like this. By using the user's corrections, the system adapts the internal model into the user at online. First, this is the initial result before adaptation. Next, the user corrects a few undesired beats and presses the optimize button. The system then starts the adaptation iteration of the internal model. This is the result. This region is not directly edited by the user, but a natural result is obtained. Our model architecture for producing the beat activation function would be changed between training and runtime. During training, we train our model using only a local context. At runtime, we split the model into two blocks and insert a novel adaptive runtime self-attention block between them. This adaptive runtime self-attention enables to distribute the loss derived from the user's local modification to the entire input sequence globally. To prevent the undesired modification after the adaptation, we incorporate an additional interactive process. When the user edits a beat, the system first shows the beats that are expected to be significantly affected by the user's modification. The user then judges whether they really need to be correct, and assigns positive or negative labels to them like this. The assigned labels are used for weighting the attention map in ARSA module by computing the Fisher's criterion. This weight reduces the effects from the user's modification on the frames that the user does not want to be changed. We compared the results with and without ARSA. In this experiment, the system automatically corrected the highest error beat, and then iterated the adaptation iterations 100 times. We repeat this procedure 5 times. This is the result. Compared to the method without ARSA, clearly, we can see that the errors in our method tend to converge to smaller values with fewer modifications. Next, we conducted a user study. In this experiment, we asked 5 participants to correct the errors of the target musics as quickly as possible using our system. As the result, almost all the subjects completed the task in less time than the durations for pieces. This means that our interface has significantly improved the efficiency of the error corrections. Thanks.